Greetings one and all, and today we are going to discuss about scalar product and vector product. We are going to first discuss what is a scalar product. Scalar product, as the name suggests, it is a product of two vector quantities. Whenever two vector quantities multiply, whenever two vector quantities are multiplied, and they ultimately form a scalar quantity. When two vectors, when the product of two vectors are multiplied together and obtain a scalar quantity, then this type of product is considered to be scalar product. If the product of two vectors is multiplied together to form a scalar quantity, then this quantity is considered to be a scalar product. Similarly, on the other side, we are having vector quantity. Now, if two vectors are multiplied, if the product of two vectors is considered to be a vector quantity, then the product is considered to be a vector product. Simple. So here, whenever we produce a scalar product is basically produced on the line where there is a presence of y-axis. Oops, I guess let me just define this diagram so that we may further conclude on what I'm going to decide. So here, for suppose we are having a Cartesian coordinate system, in which there are x-axis, y-axis. This is origin O, and we have drawn two vectors, vector A, which is on the x-axis, vector B, which is also on the x-axis. Now, there are two vectors, vector A and vector B, which are having magnitude. These are two position vectors. So two position vectors, vector A and vector B, are having magnitude A and B, which are making line OD and OC, making an angle theta at x-axis, because angle OC is also at x-axis, OD is also at x-axis. So that is why we consider it to be the definition of this diagram. After which, um, as we know that both of these are on the x-axis, both of these are on the x-axis, we consider it to be moving. Both of these are on the x-axis. So on the x-axis, what is the quantity of, what is the trigonometric ratio utilized? The ratio which is utilized here is cos theta. X-axis is having its trigonometric ratio cos theta. So here in the scalar product, the product obtained is a scalar product, and it is having trigonometric ratio cos theta, as the theta angle is made on the x-axis. Apart from this, we are having examples such as we are having electric flux. Electric flux is having its formula as electric field intensity into area. Both of these are vector quantities. Area is also a vector quantity, because if we are gonna find the direction of area, if we are gonna suppose to divide the area of a circle or area of any shape, then that area, in order to be divided, requires a direction. So here it requires a direction, so area is also considered to be a vector quantity. Now both of these are vector. When these multiply together, they form electric flux. Now electric flux is basically a scalar quantity which is formed by the product of two vector quantities. And whenever there is a scalar quantity, then we utilize a dot between the both of the vector quantities. Now whenever there is a dot in between, whenever there is a dot between two vector quantities, that is known as dot product. Whenever there is a cross between two quantities, that is known as a cross product. Both of these are not same, but these are some quantities, some conditions which we need to look into. Dot product is not a scalar product, nor the vector product is a cross product, because any quantity, two vectors having dot between them is dot product, two vectors having cross between them is cross product. This is how it works. And after that, we are having other examples such as work is equals to F dot D. Work is equals to F dot uh, S. Now after removing dot, we are gonna utilize the trigonometric ratio cos theta. It will become W is equals to Fs cos theta. Now we are having some certain conditions. Whenever two vectors, whenever the scalar product of two vectors, for suppose this is these are two vectors. If the scalar product of two vectors is in such a manner that two vectors are having their direct both of the vectors are parallel to each other. If you're having two vectors parallel to each other, then the scalar product will be maximum, because cos 0 is equals to 1, due to which it will become maximum if two vectors are unlikely parallel to each other, unlike parallel to each other. So the scalar product would be negative, because cos this will be forming angle 180, it will be equal to negative, negative or minus 1. So here we are having another one in which if there are two vectors which are perpendicular to each other, so suppose vector A is going in x-axis, vector B is going in y-axis, both are perpendicular to each other, so this would be having its scalar product as 0. Why would it be having its scalar product at 0? Because uh, it would be having its scalar product as 0, because cos 90 is equals to 0, as well as if these are arranged in such a manner that cos theta is equals to cos 70 270, so cos 270 is also equal to 0, so that would be also having 0 scalar product. Now accordingly we are having some other condition that here, as you can see, we are having the unit vectors as well, I, j, as well as k, I, j, k. Now unit vector I, if you are having unit vector I and this unit vector I, for suppose if you are having the unit vector I and we are going to multiply unit vector I with unit vector I, then what would be the answer? If unit vector I is multiplied with unit vector I, then what would be the answer? Answer will be 1. Answer will be 1. Whenever we are going to multiply unit vector with its own unit vector in the scalar products, then answer will be 1, because it is having value it's 1, it is having its value is 1, and both are in the same direction. I and I both are in the same direction. Of course, if this is I x-axis, this would be also I x-axis, both are in the same direction, then cos 0 would be equal to 1. So ultimately it will be equal to 1. So whenever they are same vectors, I into I, it is 1, j into j 1, k into k 1. Similarly, if we are having two different unit vectors, I into j, if you are having different unit vectors I into j or I into k, then what would be the answer? The answer would be 0, because if you are having two unit vectors, for suppose let me draw the coordinate plane, um, oops, where we were here, right? So here, if we are having uh, this, let me just add another page. Now here, for suppose this is a coordinate plane, and I guess we should rather utilize a sign for x-axis. This is x, this is y, this is z, and rest of the lines are useless. These are of no use to us, so we are going to neglect it. So here this is x-axis, y-axis, z-axis. Now for suppose this is I, for suppose this is z, this is I, this is k, and when I and k multiply, we know that all of these are mutually perpendicular to each other. As these are mutually perpendicular to each other, so whenever these will be multiplied, these will collectively form the angle of cos 90, which is equal to 0. So I into k or I into j or j into k or j into I, or whatever the condition is, whenever two different unit vectors multiply in scalar product, the answer would be 0. Um, so this is how we are supposed to do it. And apart from this, if we are multiplying a dot b, so suppose this is scalar product a dot b. Now scalar product a dot b can be b dot a, can be b dot a, which means it follows a commutative rule. If we are changing their positions and multiplying them, there's no effect on the answer. So a dot b is equals to b dot a in the scalar product, which means the commutative law is fulfilled, is applied. On the other hand side, we are having vector quantities. Vector quantities are those quantities which are having their product as vector whenever two vectors are multiplied together, and these are having their trigonometric ratio as sine theta. Why is it sine theta? Let me just write first. It is sine theta. And for suppose we are having a vector, this vector position vector a, which is originated from the point of origin. Now this position vector a is originated from point of origin. As it is originated from the point of origin, this is basically making an angle theta alongside the x-axis. It is making an angle theta alongside the x-axis. Now when we are gonna uh, when we are going to break it down into its components, when we are going to do its resolution, so it will resolute in such a manner that here that would be the y-axis ay, that would be the x-axis ax. So ultimately this is ay, this is ax, and this is a. Now uh, here in this condition, uh, a is basically having uh, a is basically having ay. A is having ay, and in such a manner that, let me just first draw it down. So here uh, a is having two components, ax ay, and accordingly ay, a is equals to radical ax whole square, ax whole square plus ay whole square, ax whole square plus ay whole square. So this is the formula which we have collectively obtained. But here in this formula, we have to obtain the angle theta. Now this angle theta lies along which axis? Now as we know that this is the let me just have this. This is ay, this is ax, this is a. Now angle theta lies on uh, the point where where base and hypotenuse are present. Now opposite to this angle theta, we are having two lines ax and ay, and in this condition whenever there is ay and ax, that is considered to be tangent, or oops, let me just confirm it. There is a mistake here. So here now this is ax, this is ay, this is a. Now as we know that this is angle theta. Now angle theta is having it in its opposite direction. There is this in its opposite direction. The lines which are in its opposite direction are the perpendicular line ay, and and the hypotenuse, which is a. Now as we know that perpendicular upon hypotenuse is equals to what? Is equals to sine theta. As it is perpendicular upon hypotenuse equals to sine theta, so trigonometric ratio here would be sine theta as well. We'll further discuss how to solve multiple problems in regard to it. So now in this condition, if the angle, if there are two parallel vectors, then the vector product would be 0. And if there are two unlike vectors, if there are two unlike parallel vectors, the answer would be 0 as well, because sine 0 and sine 180 is equals to 0. On the other hand side, the vector if the vectors are arranged perpendicular to each other, then the if the vectors are arranged perpendicular to each other, then both of these vectors will be having their answer as maximum or as positive. The answer will be maximum as or positive. If they are having their angle as 270, or if they are having their angle as 270 in the opposite direction, if they are perpendicularly arranged in the opposite direction, then that would be 270, and sine 270 is equals to minus 1, which means that would be resulting into a negative vector answer. So this is how it will work. And now if we are going to utilize the formula for unit vectors, I into I. If we are going to multiply I with I, both are unit vectors, both are in the same direction. As these are in the same direction, these are parallel to each other, the answer would be 0. Why? Because when these are in the same direction, the answer would be 0, because sine 0 is equals to 0. If there are two different vectors, well, suppose this is I, and for suppose this is J, this is being taught in the condition of vector product. If there's vector product, then this is applicable. Otherwise, in scalar product, there's a different condition which we have previously discussed. I into J, both of these when multiplied together, they form first of all a mutual perpendicular angle, because I is perpendicular to J, J is perpendicular to K, K is perpendicular to I, and all of these are mutually perpendicular. So both of these are perpendicular to each other, so sine 90 is equals to 1, which means the answer would be positive. So whatever the value of I and J is there, when these are gonna multiply, these will produce their value. When they are gonna multiply, these will produce their value as a positive value, or we can also call it as 1, because both of these are having their value as 1, so it will be a positive one. After which, after which we are having another condition here. We are going to discuss the right hand thumb rule. So for suppose we are having the same vectors. Let me just erase all of this. All right. So here we are having the same vector, and we are going to utilize the right hand thumb rule. So for suppose this is AX. This is what we call as the AX. Now AX is arranged in such a manner that it is in the x-axis. Now this is considered to be the thumb. This is considered to be the palm of our hand. This is the palm of our hand. It is considered to be the palm of our hand, the palm of our hand in which there is x-axis. Now as we are gonna fold our palm, as we will fold our fingers, when we are gonna fold our palm, create a curve in our palm, so it will collectively form what? It will collectively form the direction of AY. This is AX. Then when we are gonna fold our palm, then when we are gonna fold our fingers, fold our palm, then it will form AY. And when we are gonna straighten the thumb, our thumb is on, of course, on other hand side. If we are gonna move our palm on this side, thumb would be on the other hand side. So when we are gonna straighten the thumb, so when we will straighten the thumb, that would be the direction of the resultant force. This is known as the right hand thumb rule. And according to the right hand thumb rule, that is utilized to determine the direction of the resultant vector. As it is in the case of this, in order to identify resultant vector A, we are gonna utilize right hand thumb rule AX, then fold the curve, fold the palm, and form AY, and then straighten the thumb, due to which it will form A. Now there's another rule which is known as right hand screw rule. Now as we know that whenever we um, unscrew something, so whenever we unscrew something, the screw always moves in the anti-clockwise direction. Screw always moves in the anti-clockwise direction. For suppose this is vector A, this is vector B, and whenever a screw moves in anti-clockwise direction, its direction is considered to be positive. Now this is vector A, this is vector B. Now screw, when it moves in the anti-clockwise direction, it moves upwards. It is opened. So in order to identify the direction of the resultant vector A into B, for identifying A into B, we will be changing, we will be moving the screw anti-clockwise, and when it will go upstairs, when it will go upwards, first from A then to B, and then ultimately towards the resultant vector, which would be C, for suppose C. So here we can say that A dot B is equals to C. A dot B is equals to C. Now we are gonna do another experiment here, that we are gonna move the screw downwards. As we will move it downwards, it will become a clockwise direction, as it would be a clockwise direction. So that would be a clockwise direction, opposite direction, due to which B dot A is equals to minus C, or we can also write it as minus D. So minus C, why? Because it is in the opposite direction of the resultant vector. So when we are gonna add A dot B is equals to B dot A, then both of these are not equal, because A dot B is equals to C, A dot B dot A is equals to minus D, which means both of these are not equal, which means this does not follow the commutative law. And this is about vector quantity, vector product, as well as scalar product. And apart from this, let us discuss an example, very famous example, torque. Torque is equals to Fd sine theta, Fd sine theta, and all of the conditions are discussed previously, as well as there are other formulas as well, such as angular momentum. Angular momentum includes what? Includes this formula, momentum into position vector. Torque includes this formula is force into position vector, as well as there are other formulas such as torque into position vector. And apart from this, there are other formulas such as, all right, there is torque, there is angular momentum, as well as there is example of magnetic force. Magnetic force equals to F is equals to Q V into B, where Q V B, V and B are perpendicular to each other. These are vector products, and charge is scalar product. When these multiply, they form a vector quantity, which is magnetic field. And I guess that's all about today's video, and hopefully we'll meet in another